Hi, my name is Ryan Corrigan, and today I'll be talking about race, gender, and urban tree canopy. For a quick introduction, we need to look at the urban heat island effect. The EPA describes it as it's when cities replace natural land cover with dense concentrations of pavement, buildings, and other surfaces that absorb and retain heat. This essentially creates this bubble effect around these urban areas that make them a lot warmer than the surrounding rural areas because there's less natural foliage to help cool the surrounding area. This can become even more important as climate change makes these severe heat waves more frequent, it causes global temperatures to rise. Because of this, cities need to learn to adapt and to identify the vulnerable areas that are most impacted by the urban heat island and are going to be in the future. A primary way that cities can and already are doing this is by adding more vegetation in urban areas, which is the primary focus of this presentation. When conducting my literature review, I wanted to primarily look at how the urban heat island effect is impacted by factors such as race and gender. So first with Wilson in 2020, they found that race can impact who is exposed to urban heat, primarily by looking at what areas were formerly redlined in the 1950s. Because of this, we see that these sections of the community suffered from chronic disinvestment, where the Class A communities got most of this investment because they were encouraged to by these redlining practices, where the Class D communities did not get this investment in the same manner. Looking at Baltimore, for instance, Wilson found that the land surface temperature of areas that were formerly considered Class A was 88 degrees Fahrenheit, where the Class D communities was 97 degrees Fahrenheit. These temperatures were taken at the same day, at the same time, in the same city, just in different neighborhoods of that city, which highlights how there's stark differences um, driven by these racial practices. Additionally, they looked at the normalized difference vegetation index to look at basically how much vegetation is in that given area on a percentage level. So in these Class A communities, it was 36%, where Class D was 14%, which corroborates previously how we talked about the impact of vegetation can have on temperature of a given area. Additionally, Mashuti highlights how gender can impact who is exposed to urban heat. They looked at the percentage of women minus the percentage of men to see what areas had more or less women, to see what impact does gender have on who's exposed to urban heat. In this, they did a case study of the Netherlands, and the result was they found that as the percentage of women minus men increased by 1%, the land surface temperature of that area also increased by 0.1%, or by 0.1 degrees Celsius. This highlights that while women aren't necessarily causing this urban heat problem, it's indicative of the larger societal structures that place women in these areas that are going to make them more exposed to urban heat than their male counterparts. This led to my research question because I wanted to look at it in a more intersectional lens to look at the combination of race and gender, rather than just looking at race or gender independent of each other, like Wilson and Mashuti did. So my research question that I asked was, do census tracts vary in tree canopy coverage based on demographic factors? For my data to answer this, I looked at data from the US Census Bureau in 2020, the Tree Equity Score, and the Google Environmental Insights Explorer to help get the information I needed about things like urban tree canopy, heat, race, and gender. Because of this, my unit of analysis was the census tracts of Kansas City, Missouri, and Jackson County, so I could really focus on this one city and how the different areas of that city are impacted. First, I wanted to look at race to help try to corroborate some of the evidence that Wilson had found in Baltimore. In the evidence, we looked at the HOLC grade, so the red line communities. The blue area is seen as still desirable, but not perfect, whereas C is seen as declining and was seen as hazardous. Because of this, we can see how these maps made in the 1950s still impact who lives there in the present, where we can look at the white female and white male populations primarily live in areas that weren't considered declining or hazardous, where the black female and black male populations still live in these areas that in the past were considered hazardous and in the past were made up of people of more marginalized groups, which just shows how these past decisions and past biases within land use are still impacting people today and where they are living and exposed to urban heat. Next, I wanted to look at specifically the tree canopy coverage in relation to the urban heat of that area. The map on the left looks at the tree canopy area percentage to see how much of that given census tract is made up of trees and covered by trees. Because as we can see, that has a pretty clear connection with the map on the right that looks at the temperature difference. 0 on that map is basically represents the average temperature of the Kansas City area. Anything above that is going to show that's warmer than average. Anything below that is going to show that's cooler than average. So these dark red areas are warmer than average, and the light blue areas are cooler than average. When we compare this to the tree canopy map, a pretty clear pattern presents itself, where the areas that have more trees are going to be cooler than average, where the areas that have less trees are going to be warmer than average, which is important when we consider the urban heat island effect and the role that trees can play in combating it. Next, I wanted to look at the combination of race and gender. With the box plots on the right, we look at the 4 distinct groups I focused on, which were black men, black women, white men, and white women. Because of this, I wanted to look at how these different groups are impacted in the census tracts where they make up a majority of that population of that census tract to help really isolate how are these areas impacted by tree canopy coverage given their demographic majorities. As we can see, black women and white women have a lot higher tree canopy areas than I probably would have assumed going into this within my sample, where white men have a lot lower tree canopy coverage, which is important to recognize with that last slide, where we talked about how the less tree canopy coverage you have, the more likely you are to be exposed to the impacts of urban heat at a higher than average levels, which is important to look at how these different groups differ in the different ways when it comes to tree canopy coverage. Next, I also wanted to look at the population density because it was pretty clear when we look at the population density box plot on the right that as population density increases, tree canopy coverage decreases, which just makes sense because obviously as there's less area for trees to take up, there's not going to be as many trees if you need that space for things like buildings and houses, which is an important consideration to make. So that kind of diminishes how much race and gender may impact this specifically, and population density may be another variable to consider in the future. To look at this in a more statistical sense, I ran an ANOVA test, which essentially just compares the mean between multiple groups to find if there are significant differences. We're basically looking at, is the tree coverage among these 4 different demographic groups, is it different just by chance alone, or is there actually a pattern here that we can find? When we did this analysis, I got a p-value of 0.0341, which is statistically significant, proving that this isn't just chance alone that these groups are going to differ, that there actually is a difference between some of the groups. Because of this, to build upon it, I ran a 2-key HSD used to find which groups are statistically significant. The ANOVA test just says, are the groups significant, or are the groups different, yes or no, where the 2-key builds upon it to see which groups are different. When I did this, I found that the white men group and the black women group had a significant difference, and the white men group and the white women group has significant difference, which just highlights the differences is apparent in these different groups and not just caused by chance alone, specifically within white men and black women, and then white men and white women. So in conclusion, we rejected the null hypothesis, which means that race and gender do influence a census block's exposure to urban heat. All of the groups don't have the same tree coverage, which is significant to realize this, to show how past discrimination can possibly still influence present vulnerabilities, but also just to look at it in a more intersectional framing. Because we didn't see that black men and black women had the same, and white women and white men didn't have the same. There's obviously variables beyond just race or just gender that become more apparent when we look at it in a more intersectional lens. Future research can build upon this by studying other cities outside of Kansas City, Missouri, just to see what it's like in other parts of the country. Additionally, it's important to include more than just white or black when studying race. Because of limitations on time and resources, I only looked at white and black to help simplify my analysis. But it'd be important to look at other studies on topics like this that include more, are more inclusive when it comes to race, rather than just looking at it at 2 potential categories. And then finally, also future research can work to study the impact between race and gender on population density, since that was a confounding factor that I think would be important to recognize and the importance that it has on urban heat. So for some quick acknowledgements, I want to thank you, Dr. On, for their help throughout the research process. I would not have been able to complete this project without the help of their teaching resources and guidance to improve my understanding of statistical and spatial analysis. And I also want to thank my family for giving me the opportunity and encouragement to study at KU. And thank you for watching. I hope you learned something and have a good rest of your day.